Okay, welcome back. This is video 4 of my Grey Hat Python presentation, and where we left off we were looking at DLL injection. So there is a file in the Grey Hat Python source called dll_injector.py, and if we look at that script, you can see it's actually pretty short. It's only 40 some odd lines with some generous spacing and formatting and things. Some of the key things we're going to do is we're going to pass in, let's see, a process ID, and then we're going to try to open that process or get a handle on it. You can see we do that there. If we don't, we're going to fail. Next thing we're going to do is we're going to allocate some space for the DLL path, and then write that DLL path into that allocated space. So we're going to do that with that write process memory here. The next thing, and this is what I talked about earlier, is that load library A. That's what Windows needs, the Windows process needs to load DLLs into memory. So the first thing that we need to do is we need to resolve the address for the load library A, which we do by saying get module handle and loading the kernel 32 DLL, and then get the address and load library A function. So here's the handle opening into that library, and then here's the function getting the address of that. The next thing we're going to need to do now, and this is the heart of it, is we're going to try to create the remote thread with the entry point being set to the load library function and the pointer to the DLL path as its single parameter. So we're going to try to inject a DLL into a running process, create a new thread, point to that DLL and load it. So you can see here we've got the create remote thread method. If it does not work, it's going to fail. If it does, then we're going to see, in this case, we're going to see a message box. So if we look at what the book sent is this GHP inject.c++. This is all it is, and then the author compiled it into a DLL. So you can see we're just going to have a message box show up. Hello from the process, I'm inside the process you injected. So all that's left is we've got, command window going. I got task manager going, so we can see the process ID is 3096, and if we look at the directory here, this is the directory I'm executing out of. We can see that I've got that DLL just in that same directory as my script. So if I run Python DLL injector, I send it these two arguments, the process ID and that DLL to inject into. We should see I'm going to pause it here real quick because that should have worked. Okay, well, believe it or not, you actually have to run that command as an administrator. So I've got this pinned to my taskbar. If you right-click on that and then right-click on that, you can run it as an administrator. And now what we should see when we run that command, we should see that we've injected that DLL, which is just simply a message box. Hold on. Okay, third time's the charm. I ran this the last time while I wasn't recording, and I needed to actually close that shell and open a new one. So Python DLL injector, there's my process ID, and then that DLL. So when I execute this, there is the message box that popped up. So I just successfully injected a DLL into a currently an active process. So again, you can see a lot of power available in being able to do that. So that is a very brief intro into DLL injection. The next area is code injection, and the whole objective of code injection is to insert raw shellcode into a running process and then have it executed immediately. One of the really cool features about this is that it leaves no trace on disk. It's all done in memory. The other cool thing, and this is where it starts to get very nefarious, is that it allows the attacker to migrate their shell connection from one process to another. You can just keep injecting. So with that, I'm going to go ahead and show you. I've got the goal of this now is to create, and what the author has in the book is to create a backdoor, and that'll be my assignment, is to look at using code injection to actually create a backdoor. So some of the files that we need to look at will be this backdoor itself. Okay, so the idea behind this backdoor is that we're going to create a Python script that then we can then actually compile into an executable, make it look like an existing program, have that person, have our target, fire off the executable that we create that's going to attach itself to the real executable. So we're gonna focus on calculator here. Attached to that, so fire off an instance of the real process, the real calculator, inject a backdoor, and then kill itself off so that the real calculator is the only thing running in the end. And hopefully this is all completely transparent to the end user. This will be the I guess the assignment that I've created, is to go through the examples. I'm going to attach the code in the discussion, and be able to actually get this to execute and connect back to yourself. The files that you'll need will be backdoor.py, backdoorshell.py. This is just simply what you can use to connect. Hold on one sec. So the code that I'll attach, whatever environment you want to run this in, so that would include a target machine, probably the same Windows machines you've been using throughout this class. Backtrack 5, because you are going to have to generate your own shellcode in order to actually get the right shellcode to connect back to you, and then the download, install the Pi2exe program, and I'll leave that again as part of the exercise, is getting familiar with that. So we will step through the code here quickly, just to get an overview of it, and then that'll conclude my presentation, and I'll create I guess a solutions video. So this is what we're going to look at, is a lot of this information. You don't necessarily need to fully understand it in order to be able to actually get this to work, but this code is fairly well commented. So one of the first things we do is fire up that second process and store its process ID so that we can do our injection. So they'll click on our executable, and then we'll right away fire off the actual calculator .exe. So that's all that we're doing right there. We'll get back to that inject. Here is our first connect back shellcode. This is actually the shellcode I generated to connect back to myself. We're going to inject that connect back into that second process that we fired off, or the actual calculator. And then this is he calls it killer shellcode, but this is what will actually kill that first process that we kicked off. And then you'll see we do some padding, we replace value, replace string, have the new process killer shellcode, and then we inject again. So now if we go back and look at this injection, and what we'll see here is that we get that handle to the process we're injecting into. So as we kind of worked our way through this presentation, you'll see a lot of these concepts are building on simple things we did at the beginning. Now we're using them to actually do something that has some real power. We write the process memory, and then we try to create that remote thread. So I'll leave some of the finer details of digging into this up to you as part of the assignment. The backdoor now is the other piece, and this just simply is just a simple opens a socket and listens for something to connect back. You could simply use Metasploit if you wanted to. This is out there. It looks fairly similar to some of the other scripts that we've used for some of the other exploits. But it sets the server, the host, the port, the socket. So this is going to do whatever your shellcode is set up to do. The listen, and then just go ahead and listen. Once something finally connects back, it'll spit out something that somebody's connected. I haven't actually been able to send commands back and forth, but I was content just getting the calculator thing to work and connect back to myself. So at this point, I'm going to wrap up my presentation, and then I'll also post a solution video to watch and see it happen. If anyone has any questions, please contact me through the D2L website, and I hope you enjoyed this presentation.